Welcome back. Assuming you've watched other videos. If you haven't, watch the other videos. Hi, bo. This is YouTube bully. But yeah, welcome. We're looking at IEB May 2023, paper 1, question 12a. Right. Sequences and series. In a geometric sequence, S5 is equal to 605 divided by 243. Okay, so the sum of the first 5 terms is equal to 605 divided by 243. And term n is given by w times 3 to the negative n. Okay. Right. Determine the value w. Yay, man. Okay. Let's see. My first instinct is right to just use the geometric series formula, right? So that formula tells us that the sum of the first n terms is given by a times, r to the n. Let's just total it, hey. Minus 1 divided by r minus 1. Okay, maybe let that be our starting point. So we don't know what a is, we don't know what the first term is, we don't know what r is, because the formula for a term is a times r to the power of n minus 1, and this doesn't really look like that right now, so how tricky. Is it? Okay, let's see. For now, I will not try to manipulate it to get it to look like that. I'll do that if I hit a brick wall. Right, so yeah, right now we don't know what r is. So S5 would then be equal to a times r to the power of 5 minus 1 divided by r minus 1, right, which would be equal to 605 divided by 243. And we can do a bit of ninja stuff to rearrange this equation as 243 times a times r to the 5 minus 1 is equal to 605 times r minus 1. Yeah, I'm just gonna leave it at that for now. I'm definitely confused. So confused. Yeah, I'm gonna park this for 2 seconds and see if something else makes it make sense to me. Oy. Yeah, I shouldn't write on the picture, hey. Not good. Let me try and fix that actually. Now the thing is attached. Oh, Lulu. Okay, right, let's sort this out, hey? Okay, now let's shrink this. Yeah, guys. Okay, so now let's go to what I had thought I might need to do, but I wasn't sure. So I'm going to try and rewrite this so that it looks something like this. Let's see how successful I can be. So Tn is equal to W times 3 to the power of negative n, right? And our n doesn't have a negative in front of it in the formula. So I'm going to rewrite this so that we have a positive n, all right? So this will be 3 to the minus 1 to the power of n, right? Because if you raise to another power, you just multiply the powers, right? And that is pretty much the same as W times 1 over 3 to the power of n. Okay. And now I want a minus 1. I don't want an n, I want an n minus 1. So in order to do that, right, remember, like, if I have a number and I times it by 2, okay, so obviously the number is going to change. But if I also divide it by 2 rather, so let me not say times by half. So if I times it by 2 and also divide it by 2, then I still just end up with 3. So I haven't actually changed the number. So I want to see if I can use this trick, okay? All right, so if I want a minus 1, that means I want to times by 1/3 to the minus 1, right? Because then I'd have 1/3 to the power of n minus 1. But then that means I must also divide by 1/3 to the power of minus 1. So this is 1 in disguise. I'm just timesing by 1. So I'm not actually changing this, right? I'm just trying to see if I can find a different way of expressing it, right? So let's see. So now on the one hand, okay, this becomes what I want it to become, right? This now becomes 1/3 to the power of n minus 1. So then that means I need to simplify this so that it becomes something of its own, right? So if I just come to a corner real quick here, W divided by 1/3 to the minus 1 is just the same as W, right? This minus 1 makes the numerator and the denominator switch around in very informal terms. So this just becomes a 3, right? Or another way that we can write it is 1/3 of W, right? W divided by 3 is just the same as 1/3 of W. Okay, right. So let's move this somewhere here. Okay, so this becomes 1/3, oops, 1/3 of W, right? So now this is helpful to us because that means A is the same as 1/3 W, and we now know our R is 1/3. Ha ha! Ha ha! Is that ear piercing? I'm sorry. Okay, so let's also just clarify. Maybe let's move this again. Sorry. Okay, so let's just clarify that this we simplified over there. Okay, so this is looking, it's definitely giving me goosebumps now. It was looking bleak for a hot second there, but we are back on track as we're back on track. So I'm going to take, right, A and replace it with this expression 1/3 W, because we want to solve for W, so we want our equation to be in terms of W, right? And then R which is a third, right? We're going to raise that to the power of 5, subtract 1, and we're saying that that is equal to 605 times a third minus 1. Okay, so we need to shrink some things. Oh, it touched the bracket. Okay, and we're moving things again. Okay, right. So on the left-hand side, we've got 243 times a third, which is 81 W. And then inside here, we have a third to the power 5 minus 1. And I think that gives us minus 242 divided by 243, right? And then over here, we have 605 times a third minus 1. I'm going to bring up the calcs for that. 605 times a third minus 1 gives us negative, yay man, yeah, it must give us the fractions. Negative 1,210 divided by 3, okay. And then on this side, on the left-hand side, I'm going to multiply 81 with negative 242 over 243. All right, and that gives us negative 242 over 3. W is equal to negative 1,210 divided by 3. We can then divide both sides by negative 242 divided over 3, right, in order to get this W by itself. Okay, so let's calculate that. We've got negative 1,210. Oh, let's just clear everything. Oy. Negative 1,210 over 3 divided by negative 242 over 3. Right, and that gives us such a beautiful little answer, man. W is equal to 5. Right. And of course, you know, if you have time in your exams, always good to just try and do sanity checks, man. Do sanity checks. So what I would do, for example, if I was at the end of my exam and I had a bit of time left over, I would take this value of W5 and I would put it in here, right? So Tn, the formula that we use to generate each term in this sequence, is 5 times 3 to the power of negative n. So the first term will be 5 times 3 to the negative 1. Second term, 5 times 3 to the negative 2. 10th term, 5 times 3 to the negative 10. So I would then generate the first 5 terms using this formula and then add them up and see if I do indeed get 605 divided by 243, because then I'll know that, yes, I have found the correct value of W. Let's check what the memo has to say. We are looking at question 12A. It says the answer is 5 over 3. Oh, no. The horror. The sheer horror. Okay, so let's try and trace where I went wrong. graphic, I'm telling you. Okay, I'm gonna try and see where I went wrong. Okay, so let's start over here. Okay, so I know that that formula is correct. Then we were told Tn is equal to W times 3 to the minus n. And so I rewrote that as W times 3 to the minus 1 raised to the power of n, which is true. Minus 1 times n gives me minus n, which is the same as a third to the power of n. Yes, I stand by that. Then I wanted to get this to be a third to the power of n minus 1 so that it looks like this formula. So I multiplied by a third to the power of minus 1, but then that meant I needed to also divide by a third to the power of minus 1. So on the one hand, this bit of the expression ended up being a third to the power of n minus 1, but this bit of the expression we needed to simplify. So we have w divided by a third to the minus 1. Another way to look at this negative 1 power is it would be the same as me taking this third to the top of the fraction. So that would be w times a third, which is w over 3, which is a third w. So this part of the expression simplifies to a third w. So we have Tn is equal to a third w times a third to the power of n minus 1. So on those grounds, I concluded that r is a third and a is a third times w. Right. So we know that geometric series, this is the formula to work out the sum of the first n terms. We were told that S5 is equal to 605 divided by 243. So then I put in, okay, a, I don't know, I didn't know at that point. I started on this side, okay, so I didn't know what a was at this point. And then times r to the 5 minus 1 divided by r minus 1 is equal to 605 divided by 243. Good. So then we manipulate the equation. There's another thing that maths teachers, we don't like it. Some do, some don't. But this thing called cross multiplying, right? But it's essentially just a shortcut for simplifying equations like these where you have fractions on both sides. You multiply 243 with this guy, so that's how I got this one, and 605 times that guy, that's how I got that side. It's just a shortcut for doing those times. Is the alternative would be to do them one by one. So you would times this side by 243 and then times this side by 243. Oopsie. Right, and then you would times this side by r minus 1 and then times this side by r minus 1 as well. So that's pretty much what's going on behind the scenes. Anyway, yeah. Scribbles. Okay, so that's how I ended up here. I'm still confident about that being correct. So then we took the a, right, and we put it in there. And then we put the r in there, and likewise on this side. Okay. So maybe what I want to double check with the calculator is 243 times a third times this number. Does that in fact give me negative 242 over 3? Let's see. If it does, I'll be so confused. Right, so 243 times a third times a third to the power of 5 minus 1, right? That does in fact give me it does give me negative 243 over 3. So that's a relief, I guess. In some sense. Then the next thing I need to double check is whether the right-hand side evaluates to what I think it evaluates to. Okay, so 605 times a third minus 1 does give me negative 1210 divided by 3. And then I divided that number by negative 242 over 3, and that gave me 5. Okay, so this guy can go back to the drawer. Okay, so let's just see what we have here. So we have W is equal to 5, and that's what we wanted. W is equal to 5. So then the next thing I'm thinking is, okay, let's not dragging out longer than it needed to, but let's actually then just test if this W value of mine does work. So T1 would be 5 times 3 to the minus 1, so 5 over 3. T2 would be 5 times 3 to the negative 2, which would be 5 over 9. Okay, we can kind of see how this is going. So T3 will be 5 over 27. And you can verify this if you are feeling trepid. Right, and T5 would be 5 over 243. Right, so these are the values that we need to add up. 1, 2, 3, 4, 5. So let's get Mr. Calcs out. Okay, so 5 over 3 plus 5 over 9 plus 5 over 27 plus 5 over 81 plus 5 over 243. That does give us what we want, 605 divided by 243. So the answer is 5. W is 5. It's 5. The memo says 5 over 3, which is not right. I'm sorry to say. Right, let's actually test. So if W is 5 over 3, right, then term 1 would be to the power of minus 1. Okay, and then 5 over 3 times 3 to the power of negative 2 plus 5 over 3 times 3 to the power of negative 3 plus 5 over 3 times 3 to the power of negative 4, and then one last one, 5 over 3 times 3 to the power of negative 5. That gives us 605 divided by 729, not 605 divided by 243. So, yeah, we found a place where I'm right and the memo's wrong. Yeah. Anyway, thank you for tuning in. Hopefully we will have a less dramatic next video. Hey.